This one isn't too bad. You write your givens, so you know S is the midpoint of QT. That's given. And you know that QR is parallel to TU. And I don't mark anything in my diagram to be congruent because we haven't said anything's congruent. But because S is the midpoint of QT, I know that QS is congruent to ST. Okay, and that's by the definition of a midpoint. A midpoint divides a segment into two congruent parts. I cannot label those other parts congruent because we're not given that those are congruent. Next thing, I use my other given. So right now we have a side. I know that QR is parallel to TU. So I know angle Q here must be congruent to angle T. Okay, and that's going to be alternate interior angles theorem. Okay, and I also, from this, and you can do this in different ways, but this one right here, I know that angle R is congruent to angle U. Also, alternate interior angles theorem. Okay, you can use vertical angles. Your reasoning might be a little bit different just depending on which ones. But I have enough information now because I have two angles and a side, and I make sure, is my side included? Well, I have an angle here, but I don't have an angle on the other end, so my side is not included. I know triangle QSR is congruent to triangle TSU. By angle, side. Okay, so that's that one. Okay, this next one, you know AB is parallel to CD. That's given. Knowing that these two are parallel, I can just kind of draw this. I know that this angle must be congruent to this angle. Those are corresponding angles. So I know that angle BAC must be congruent to angle DCE. And that's going to be corresponding angles postulate. And if you forget it's a postulate, it's okay. But that's one thing. Nice thing about formative is you can kind of delete these extra marks that we use to show our work. I go to the other side, and you can do this in certain orders as long as you make sure you say it before. So you also are given that side BC is congruent to DE, and here's our transversal, which also means that this angle must be congruent to this angle. Those are also corresponding angles. So I'm going to write that out. Make sure you write all of your givens. So BC is parallel to DE. That's given. And I also know angle BCA must be congruent to angle DEC. Okay, also corresponding angles postulate. Okay, so right now I have I have two things that are congruent. I also have another part. It tells me that CD is congruent to AB. Okay, that's given. So CD is congruent to AB. That's given. Now I do have enough information. I know that this is so I know for sure that triangle ABC is congruent to. Now I have to be careful. Angle A is the pink angle, so I need to go to angle C. Triangle C. Angle B is the unmarked angle, so that would correspond to angle D. And then the C here actually corresponds to angle E in the other one. And this is also going to be angle, side congruence. Once you know that, if I know that two triangles are congruent, I know their parts are congruent. So this is pretty simple here. I know that AC must be congruent to CE, and that's because corresponding parts of congruent triangles are congruent. CPCTC. Okay, so that's that one. And last but not least, this one's a little bit dicey. Okay. You're given BA is perpendicular to DA. That's given. So that tells me that angle A is right. Okay, and this one's just, so this is going to be definition of perpendicular. I also know that BC, so I know that that's right. BC is perpendicular to DC. That's given. So I know that angle C is right. And how do I know that? Well, that's going to be definition of perpendicular. Okay? I really shouldn't have put that in here. So my other piece of information, I know AB is congruent to CB. Okay? That's given. So AB is congruent to CB. And I need a third thing. So what's the other thing I tell you guys to look for is reflexive property. So I know that BD is congruent to BD, reflexive property. Okay. That said, a lot of you remember that this is angle side side. That's not a way to prove congruence, but this is a right triangle, and right triangles are special. Okay, the reason why right triangles are special is because we actually, this is not angle side side, this is hypotenuse leg. So I can say triangle ABD is congruent to triangle CBD by hypotenuse leg theorem. Okay, once I know that these triangles are congruent, well, I know things like, I know that this angle is congruent to this angle. I know angle ADB must be congruent to angle CDB. Okay, the reasoning there is because corresponding parts of congruent triangles are congruent. If those two angles are congruent, then this angle, this whole angle right here, must be bisected. Okay, so I know that BD bisects angle ADC, and that's going to be definition of bisect. So there you go.